Today we are starting with fun in graphs. The first topic, roots of the equation of the type fx is equal to gx. Consider two graphs respectively y is equal to fx. Another one is y is equal to gx. Okay? So if we consider the first graph is like this one, say this one. Another graph, say y is equal to gx, is of the type, say this one. Now we see that these two graphs are cutting each other, that is intersecting each other at two distinct points, respectively this one and that one. Name them A and B. Okay. So friends, these two coordinates should have two abscissa, say respectively x1, another one is say x2. Okay. So these 2 points x1 and x2 are the roots of the equation fx is equal to gx. Okay, this is important. This is very important. Okay, I again repeat. Say this one is the first curve, y is equal to fx. This is y is equal to fx. Okay. The second curve is y is equal to gx. This one is y is equal to gx. Now we want to find out the roots of the equation fx is equal to gx. See that these two curves are cutting each other or intersecting each other at two distinct points respectively a and b. Both the points have abscissa respectively x1 and x2. These 2 points, that is x1 and x2, both are real. These 2 points are the roots of the equation fx is equal to gx. Mind it, this is very important. Now I shall want to give an example which is very important and interesting also. Say fx is equal to x cube minus 3x square plus 5x minus 3. In how many points this graph intersects the x-axis? Okay, mind the question. fx is equal to x cube minus 3x square plus 5x minus 3. In how many points this graph intersects the x-axis? Okay, the number of points in which fx is equal to x cube minus 3x square plus 5x minus 3 intersects the x-axis is same as the number of real roots of the equation x cube minus 3x square plus 5x minus 3 is equal to 0. Okay friends? Now see that fx is equal to this expression. Okay, if you put x is equal to 1, what will happen? F of 1. See, f of 1 is equal to 1 cube means 1 minus 3 into 1 square means 3 plus 5 into 1 is equal to 5 minus 3. So we get 6 minus 6 is equal to 0. So 1 is a 0 of this function. 1 is a 0 of this polynomial. Okay, so x minus 1 is a factor of fx. X minus 1 is a factor of fx. Okay, now we shall divide this polynomial by x minus 1. Okay, to get the quotient. What will be the quotient? First of all, we shall try to find out this quotient. We show the division. Okay, x cube minus 3x square plus 5x minus 3, and the divisor is x minus 1. So x square, x cubed minus x square. Subtracting, we get minus 2x square plus 5x minus 3. Minus 2x square plus 2x. Subtracting, these two are cancelled. 3x minus 3 plus 3. 3x minus 3, 0. Remainder is 0. Now what was our equation? The equation was x cube minus 3x square plus 5x minus 3 is equal to 0. From this we are getting x minus 1 into x square minus 2x plus 3 is equal to 0. From where either x minus 1 is equal to 0 or x square minus 2x plus 3 is equal to 0. So from this we get x is equal to 1, or from this one x square minus 2 into x into 1 plus 1 square plus 2 is equal to 0, or x minus 1 whole square plus 2 is equal to 0. Friends, see that x minus 1 whole square plus 2 is equal to 0 is not true for any real value of x. You can check. Put any real value of x and you will find this is not is equal to 0. So this is not true. Hence the only root of this equation is x is equal to 1. Okay. So if you draw this graph, then what will be the shape? You see, what is the curve? X cube minus 3x square plus 5x minus 3. This one is our curve. Okay. I draw this curve. If we draw the curve of this function fx is equal to x cube minus 3x square plus 5x minus 3, then you will see that you will find that the curve will cut the x-axis at the point 1 and also the y-axis at minus 3, that is 0 comma minus 3. Okay, the curve is like this. Okay, how do I draw this curve? For this you have to see the next tutorials. Thank you. Have a nice day.